Well, good evening, friends. This is Dr. Jim Daly with Astronomy for Change, our next installment of The Sky Tonight. Today's Sunday, July 14th, and we're taking a look at the sky for, as it appears, mid-northern latitudes in North America. Last week, we talked about the sky in and around, for the summer months and the Milky Way, what the Milky Way looked like, and we spoke also about the total solar eclipse. And before I get into, that was on July 2nd, before I get into tonight's sky, I would like to revisit that moment, if we could, for something that strikes me as being rather important. To do that, we're going to change the date back to July 2nd. We want to take a look at the sky in and around the eclipsed sun and see what we can see. Okay, so let's run the time back to that point. You can see the new moon right next to the sun. You see that? If we were in South America, that's what we would see, specifically in Chile, Argentina, and Uruguay. So we're going to zoom in on this. I'd like to point out, because of the nature of the eclipse, that basically blots out the brilliance of the sun for a few moments, we get to see the sky as it would appear at nighttime or deep twilight. Okay, here we see Venus very close to the sun. Venus is the next planet in from the Earth towards the sun, and this was visible as a feature, or basically as an artifact or an aspect of the eclipse. We're going to turn the atmosphere back on, and we zoom in more. This is what the eclipse would have looked like had we been there. Okay, this is July 2nd. See the moon very close to the sun. Zoom back out. Planet Venus was perfectly visible during the eclipse. Okay. I meant to mention that previously, and just wanted to make sure I mention that now. Okay. So let's go ahead now, back to today's date. Today's the 14th. And set the date here. Okay, and this is the sun at midday. You can see now also that Venus is high in the sky. The sun is high in the sky with Venus right alongside. Okay, this is the way it appears today. Okay, we're going to move forward towards this evening sky. Okay. Okay, so let's see what's waiting for us as the sun sets and the stars begin to come out. Okay, there's Leo. I mentioned we saw Leo last time the last installment of the Sky Tonight is Leo the Lion. Show you the constellations. Now remember, Leo and Virgo are constellations of the spring, so they're going to be setting rather quickly following the sun. Okay, looking towards west-southwest and more south, we see the moon is only a couple of days before full. It's a waxing gibbous moon. The moon is to the west of the moon is Jupiter, and a little bit to the south and west of Jupiter then is also the red supergiant star Antares, right here. Okay, Antares is the heart of Scorpius the Scorpion, and it's around almost 9:30 now in the evening. Scorpio is pretty much right on the horizon, right on the meridian, the imaginary line that connects the north and the south. Okay, we're going to put that up so you can have a sense of where we are. Okay. Okay, that's Scorpio. And the moon, like all bodies in the solar system, will move through these various constellations along what we call the ecliptic, or the path of the sun, as it appears to move across the sky. And those constellations are the constellations of the zodiac. See, right here is the moon. It's in Sagittarius. Jupiter is in Scorpio, and so forth. So the ecliptic, then, this imaginary path in the sky, can be traced out like that. And if you go to the sun, where the sun's set over here, just to the west of Leo, you get a sense of the path of the ecliptic. Okay, so let's take away these markings for now, and take a little bit closer look at Antares. Antares, I mentioned, is a red supergiant star. Now, all stars basically produce their energy deep inside themselves in their cores by fusing hydrogen into helium. That process produces a tremendous amount of energy. Okay? Now, over a long period of time, the hydrogen becomes depleted, with mostly helium remaining, and the star begins to go through changes. It's a dynamic process. Stars are amazing self-regulating systems where they can adapt to changes in the fusion rate and how the hydrogen is transmuted into helium and so forth as that supply changes and it becomes depleted over time. Okay, those changes predict or cause the expansion of the star to become a giant or a supergiant star. That doesn't happen. This won't happen to our sun. Our sun will only expand to become a red giant star, but this is a red supergiant star. It's huge right here. And what I would like to do now is to share with you a diagram illustrating the size difference for Antares here. That's an image, a direct image of Antares, the way it appears, through a special adaptation of a very large telescope array in Chile. Okay, that's a real image, and you can see some changes on the star's upper atmosphere, or its photosphere, like this bright region right here. These observations are consistent with our understanding of stellar evolution, or how stars evolve in time. Okay, here's a comparison of Antares, this red giant star right here. This is what we're looking at in Scorpio. The orange giant Arcturus, and our sun right here as a speck adjacent to the other two of them. Now here's the orbit of Mars to scale. The orbit of Mars would orbit inside this star if that star were placed where the sun is right now. Okay, that kind of gives you a sense of the enormity of that star. Okay, so here, this is the image of Antares, a direct image with a special adaptation of a very large telescope in Chile. We're able to image that star, the upper atmosphere of the star's photosphere. It's fascinating. And these these various light and dark patches are consistent with our models of how stars evolve, especially stars of high mass like this star. Okay, so it kind of sets the stage, or the backstory for Antares right here in Scorpio. Now, what I'd like to do also, it was a striking evening last night, and what I'll do is I'll run the sky back 24 hours. We can see where the moon was last night. The moon was just to the east of Jupiter. It was quite a stunning sight to see the moon right next to Jupiter like that. And the previous night, on the 12th, was over here. But last night was by far quite striking. Some of you may have seen it already. Okay. As we mentioned in our last installment of The Sky Tonight, we had looked at Saturn. Now, Saturn is presenting quite well. It's what we call an opposition, where it's exactly opposite the Sun in the solar system, and the rings are presented beautifully for observation. Let's take another look at that. We'll zoom in on them. Okay, this is, as we mentioned in that installment last week, this is the view of Saturn through a very high quality, very large amateur telescope. Here, this is the moon Titan, Saturn's moon Titan, and it's the only other moon in the whole solar system that we believe to be similar to what the Earth was just following its formation. It has a nitrogen-rich atmosphere and methane and ethane lakes and seas on its surface. And it was a target of multiple passages by the now completed Cassini-Huygens mission to Saturn and Titan that was one of the most successful missions that's ever been completed by NASA and the European Space Agency. It was a cooperative project, a cooperative mission between those two agencies. Okay, so that's Saturn. High overhead. Now, before I go there, let's take a look right here at Sagittarius, the Archer. Let's put our constellations up. Right here, it looks like a teapot. It's a famous teapot, Sagittarius, right here. The ancients saw him as an archer with his extended bow, ready to launch an arrow right at Scorpius. Okay, that's what the mythology tells us about the lore of these constellations. Okay, high overhead. We're going to come back to Sagittarius, but for now, that's the view looking directly south at about 10:30 tonight. High overhead and to the northwest, we have the beautiful star Arcturus. As we mentioned when we discussed Antares, Arcturus is a red giant star, whereas Antares is a red supergiant star. There's a difference because Arcturus is very similar to our Sun if you add 3 billion years to the Sun's age. Now, I just put up an article up on our public website, and I'm going to read a few excerpts out of it to describe Arcturus. As we look up at the shimmering sapphire set low in the western sky approaching midnight, Arcturus, we are reminded that another summer is here and that spring is gone, and that Father Time continues his cadence, marking the years. It is a reminder that everything is changing and growing. It is in solace in a rather active world, one at least for a moment, to regain our center, to be in tune with the greater world and the universe above and beyond. As we look at this star, and it's set against the dark azure of the clear summer sky, if only for a moment we connect with it and all of us who are actually star stuff. We're the raw materials that were forged in the long-dead nuclear cauldrons, of long-dead stars. Arcturus stayed right at the moment, is further along than our Sun. As the seasons pass one into the next, the lesson is change, the one unequivocal constant in all of nature. We are changing, growing, aging, and Arcturus provides yet another deep lesson in this. It is an evolved red giant star, a star very much like what our Sun will be with an age of 7 billion years. By contrast, our Sun has an age of 4.6 billion years. The star is separated in time from Arcturus by only 2.5 billion years. It is the equivalent mass of the Sun, but 170 times its luminosity as a result of its expansion to 25 times the size of the Sun. Something that's a natural consequence of this transition to a helium burning process in its core, a process that builds carbon and oxygen, some of the raw materials from whence we came. If we want to know what will happen to our Sun and to us, we need look no further than Arcturus. If we take a look at an object called the globular star cluster, again, I'm going to bring up an image of this here. Okay, this is a globular star cluster just to the east of Antares. Let me go back here for a moment. Going to zoom in on Antares right here. You see right to the west of Antares right here. This is what we call the globular star cluster. It's an agglomeration of tens of thousands of stars, all bound together by gravity. These stars date back to the very beginnings of the universe. Okay, and it's such stars like Arcturus that these stars are made. So when we look at objects like this, we're looking at stars like Arcturus. This image was taken with the Hubble Space Telescope, and all these bright stars here, all these what appear to be bright orange stars, are red giant stars. Okay, stars like what our Sun will be in a few billion years. Another example, also in Sagittarius, is here. This is what we call a galactic relic. These stars in this cluster date back to the very beginnings of the universe. Okay, so let's return. We were talking about Arcturus. We go back. Here. Arcturus is in the herdsman. Booty's the herdsman. Let me just show you what that looks like here. Looks like a giant kite in the northwest. And as we approach midnight, this star will get lower in the west. Arcturus beckons red-orange, bright and friendly in our sky because it is a mere 37 light years away. A light year is the distance light travels in 1 year. So when we see the light from Arcturus tonight, if you were 37 years old, the light that left that star left it on the day you were born. Okay, interesting that when we look at the stars and to the universe, we're not only looking across great distances, we're looking across time also. So the evolved red giant star that we see as Arcturus is the same as those that populate these globular star clusters, these relics left over a very long time ago. Astronomically speaking, Arcturus is close in time and in space. It is also close to us in a profoundly deeper sense. As we look at it, we are looking at a reflection of ourselves, our destiny, our own Sun in a mere 2.5 billion years. This should give us pause to reflect on our humanity and our future together, one race on this tiny pale blue dot. Thank you, friends. I hope you enjoyed this video. We're going to be, as we mentioned, we're going to be making more of these videos, trying to get out one every week to give you a sense of the changing sky overhead. Before I go, though, I just noticed this here. Here we have Arcturus, and we look in this direction over here towards the northwest. We have the Big Dipper. It's an old saying, if you arc to Arcturus from the Dipper. right? We can arc to Arcturus from the Big Dipper. In any case, ladies and gentlemen, friends, please do like and subscribe, and don't forget free membership at our Astronomy for Change public website. Click on the red tab, and please join. Thank you so much, and keep looking up.